CEP 833 is a fully online, 7-week accelerated course, which is one of the 3 required courses for our graduate certificate in K-12 computer science education and an elective for Master's in Educational Technology students. The course is designed using Mitch Resnick's Creative Learning Spiral. Students imagine the possibilities for culturally relevant computing and creativity in cross-disciplinary K-12 contexts. They create artifacts, plans for a learning environment that supports creative computing, and new approaches to assessment. They play with new ideas and a variety of technologies. They share questions, knowledge, feedback, resources, tips, and work with their colleagues. And they reflect on their experience as a learner and apply it to crafting experiences for their own learners. Let's dive into D2L so that you can see how the creative learning spiral lives in our design. In each unit, the same structure is applied. There's a roadmap, and then we transition into imagining, creating, playing, sharing, and reflecting. Each unit roadmap provides an overview of what's ahead for the unit, so that students can organize their time and plan accordingly. Students imagine and create through the Creative Computing Quickfire. This Quickfire has a defined tool, goal, and a time constraint, which challenges them to put their reservations about creativity and computing to the side. In this example, in Stage 1, students have 15 minutes to participate in a chatbot code scavenger hunt to learn about the Python language. They then move on to modifying a chatbot, which was created by the instructor. Students then have 60 minutes to create their own version of a chatbot from scratch. A Mad Lib, a song lyric generator, a unit converter, it's up to them to decide. You'll notice that there are a limited amount of technical instructions because these are discovery-based experiences. Students are then ready to play and share. They dig into larger theories, frameworks, mindsets, and concepts in this section. The content is connected back to their Quickfire experience to reveal the big ideas that they experienced firsthand as a learner through the Quickfire Challenge. So every Quickfire challenge is then pulled apart and connected to theory in each unit. Reflecting comes next for students through computational conversations, which aim to expand perspectives regarding equity and access to computer science and creativity. Students process their thoughts in a personal developer's notebook and then dialogue about them with others in the course's Slack channel. Each week's assignment focuses on one of the stages of the creative learning spiral. In this example, the stage is create. So students reflect, connect, and apply what they learned during the unit to create an artifact that is meaningful for their context and leverages the tool and big ideas that they learned in the unit. An ungraded quiz has been repurposed for students to acknowledge that they've completed their work on time. And finally, there's a checklist in every unit which allows students to manage and track their progress. Let's take a look at some specific design choices which developed, encouraged, and sustained this creative learning community. There were smaller choices, like using a GIF to represent the multiple identities of the course instructor in the course syllabus. And then there were larger scale decisions, like the grading practices. With an awareness that students are at different stages of identifying as a creative individual, the barrier of weekly grades was removed, and all students started the course with a 4.0. This placed clear value on creativity, risk-taking, and failure, and positioned feedback as a brainstorm that encouraged ideation. Students' thoughts, reflections, work, and feedback were captured in this pre-formatted developer's notebook, which was a shared document between the student and the instructor. This developer's notebook design allows us the affordance of curating the students' multimodal creations in one place. With this student's permission, let's take a look at a completed notebook. Note that you see a reflection for the Creative Computing Quickfire. The reading notes, computational conversations, and for every stage of the creative learning spiral, there's feedback from the course instructor. Another feature to support our creative learning community is the Terms and Things document. Collaboratively, students update this with acronyms, terms, definitions of theories, pedagogical strategies, and more based on how they interpret them from readings and their experience in the course. Students were also sharing, discussing, and collaborating in the course Slack workspace. The final design choice that we'd like to highlight are the interactive Scratch projects, which have been built and embedded in D2L. The project allows students to interact with the content and models how computer science can be utilized as a creative teaching tool. Accessible transcripts are provided for the projects that are embedded in the course. Additionally, several Scratch projects are programmed with text-to-speech capabilities.
Please select the career below. Creativity is essential to particle physics, cosmology, and to mathematics, and to other fields of science, just as it is to its more widely acknowledged beneficiaries, the arts and humanities.
All of these elements work together to create a powerful and unique approach to online learning. This student experience parallels that of their own learners. It emphasizes processing and reflection, exposes them to a variety of tools and forms of computational expression, expands their perspective on critical issues in creativity and computing, and inspires them to consider the possibilities for their learning community and prepares them with information for navigating those related conversations in their context. In CEP 833, learners imagine, create, play, share, reflect, and we can't wait to start that spiral again.